Hello everybody, in this video I will demonstrate the first prototype of the SAFE project. Firstly, I will introduce the first responses of the test code, and secondly I will show the electronical component and electronical component responses in the circuit, and finally I will demonstrate the power supply management in this video. If you provide a sufficient voltage to your circuit will be directly work. This is the first responses of the electronical circuit, and this is the main power unit. The sufficient voltage level, the minimum 7.2 voltages, and you can supply your circuit until the 13 volt. And as I said before, this is the main power switch of the circuit. After you open this switch, okay, this is your circuit will respond like that. Then this is the response of the keypad. If you press a button, keypad buttons like that, as you see, the microcontroller converts its proper value and display on the 7 segment, and the buzzer create a sound for 30 milliseconds. And this is our main reset button. As I said before, this is the hardware reset. If you press one time, this circuit will reset itself directly. And this is the battery level indicator unit. The battery level indicator unit is a sensor which detects the voltage level. If the voltage level drops 6.4 volts, the LED change its status directly, and the battery level indicator detected the voltage level and give a response according to the responses. As I said before, as I said in the lesson, the PIC microcontroller needs to 5 voltages. However, there is a regulator system in the circuit. The regulator system needs more than 5 voltages to work. Therefore, we should supply our circuit more than 6 voltages. And the regulator output is nearly 4 voltages. The 4 volt is not enough voltage level for the PIC microcontroller. PIC microcontroller can work the voltage, the 4.8 voltage level and the 5.2 voltage levels. The low voltages, like 4 voltages, the PIC cannot process anything. After the 6 voltages, as you see, the system will automatically work. And this is the responses of the keypad and 7 segment and the buzzer unit. This is the crystal of the circuit. As I said before, as I explained in the lecture, crystal is a specific oscillator which creates a clock signal for the digital circuit. We won't use the internal oscillator in this project. Therefore, creating a stable square waves, we need a crystal oscillator. And this is the capacitor of this system to increase the reliability of this system. This is the filter capacitors, okay, and this is the diode. The diode will increase the reliability of the circuit. You can connect these wires in the wrong direction, but because of this diode, the system will behave like an open circuit. Therefore, you can protect your circuit. And this is the motor control unit. This is the flyback capacitor, and this is the filter capacitor. This is the Phoenix contact Clemens connector. And this is our motor, and as I said before, when you supply with the PIC microcontroller with the test code, the motor will turn automatically without doing anything. This is called the micro switch unit. You can change the direction of this motor with these microcontrollers, as you see. And this is the buzzer unit, and this is the Zener diode to filter out the unwanted signal. This is our BGT transistor, BC546 or 547. It doesn't import. This is our resistors, and please do not forget to connect this resistor 2.2 kilo or 1.8 kilo ohms to drive the LEDs onto the 7 segment. As I said before, you cannot use the LEDs without these resistors. Hello everybody, in this video I will explain the